We're going to take a look at one more example, and this table shows the humerus length, humerus is a leg bone, in centimeters, and the height in centimeters of several females. So they collected some data on the length of their leg bone and how tall they were, and want to see if that's a linear correlation. So again, our graphing calculator of choice is going to be Desmos today. And so let's go over there and plot our data. All right, looking at our data points, we can see right away, just looking at the scatter, that it does appear that this is a pretty good positive correlation, but we want to get the line of best fit to see exactly what that correlation is and exactly what the equation is. So if we put in the line of best fit, our y1 approximated by mx1 plus b, you can see that we do have an r value of 0.9847. That is a very strong positive correlation. And we can also pick up our m and our b values here to write our equation. So let's take a look at our equation. It's going to be y is equal to 3.05x plus 63.53. Notice that I'm using a decent number of significant digits there. I'm rounding to the hundredth spot. When you're doing your homework, it will tell you how to round, but don't round until the end. Keep more significant figures until you get to the very end. So find and interpret the correlation coefficient. We saw that R value was equal to 0.98, and so that means that it was a strong positive. And because it was a strong positive, then yes, that means that we have a linear relationship. Our R value was greater than or equal to 0.7, so yes, it is a strong linear relationship. Finally, they're asking us to estimate the height of a female whose humerus is 40 centimeters long. So up here, our height is our y value. So we want to know what y is when x, our humerus length, is 40. So all we have to do is take our equation and plug in that x is equal to 40 and then put that expression into our calculator. So y is equal to 3.05x plus 63.53, but we know that we want x to be 40, so I'm going to plug that in for x. And then simply put this into your calculator, and you will come up with a value y of 186 centimeters. It's actually 185 point something. I'm rounding to the same number of significant figures that looks like all of this data is to the nearest integer.